Good afternoon and welcome to the NavAir Sierra Space booth. We're about to start our final session for our time here at Sierra Space, and we're going to be talking about additive manufacturing. Additive manufacturing, it's the ability to print replacement parts at the point of need rapidly. The NavAir additive manufacturing team is responsible for coordinating with all AM stakeholders and integrating product teams in the development and execution of engineering, product support, contracting, and procurement management strategies that support 3D printing hardware acquisition and sustainment for equipment and services used to produce approved AM parts. Mr. Ted Granda, who is our next speaker, he heads the team. He's going to discuss how AM enables increased readiness, sustainment of weapon systems, and enhances warfighter capabilities. His presentation will also cover recent fleet achievements and naval aviation's next steps in AM. Now, we are coming to you live. We also have our virtual audience here today, so we'll be bringing Mr. Ted Granda up to the stage. He's going to present, and then we will take your questions afterwards. So please take your questions there. If you are in our virtual audience, we are welcome to put your questions, and we will try to answer those as well. So with that, Mr. Granda, I'm going to bring you up to the stage. Thank you.
Thank you, Michael. So it is a great honor to be here and be the anchor presentation for NavAir. I can't tell you that. I've been waiting 7 years to come and talk to you guys. So when they asked me to put my presentation together, I submitted 28 slides. That came back to me. They said, no, Ted, hey, you're right before lunch on the last day. You got to cut that back. So I agonized over which slides to show you, and they let me, my submission was 22 back, because I know you guys all want to hear about this stuff, right? No. They gave me 4. They said 4, and you got 40 minutes. And remember, you're before lunch. Right. So what I thought I would do with you guys is I would share a story, and I'd do a little show and tell. How about that? All right, good. So let me tell you why additive manufacturing is important to me. Many years ago, I had the Pioneer unmanned air vehicle, and we got into an altercation in the Middle East. And what our adversary did was he buried his tanks in the beach. He dug a hole along the beach and he parked his tanks in the beach, in those holes. So that if we shot at him, if your round landed short, all you did was spray the tank with sand. If you shot long, nothing happened. You missed it, right? All right, so my unmanned air vehicles were teamed with 16-inch guns off the USS Missouri. And all we did was we flew down the beach. We saw the pictures of where the tanks were. We radioed those coordinates back to the Missouri. And it was one shot, one kill all the way down the beach for miles. Now, unfortunately, I was the victim of some counterfeit parts in our system. And the one counterfeit part that really got me was a part that held our propeller to the back of the airplane. And it let the prop slip. I had to get those parts manufactured here in the States, get them over there as fast as I could, but I wasn't a priority on Mil-Air. I had to send those parts over myself. And my logistician cobbled together a goat trail of getting these parts from the United States down to Mexico, down to Ecuador, to South Africa, over into Bahrain, and then it was a goat trail into the theater of operations. By the time they got there, the event was over. So I could have done a lot more work after they realized how effective that UAV was with naval gunfire. And unfortunately, we missed some sorties because of that. So if I had had the ability to print that part in theater, I could have done a lot more work. That's why this is important to me. So let's talk about additive manufacturing. Let's go to the first slide. All right. So the ability to print a part when you need it, where you need it, is incredibly important to us. It improves our readiness. You don't have that aircraft or that piece of equipment sitting down waiting for a part. Makes us much more agile. Now we're not waiting to carry our iron mountain of supplies with us when we go in theater. We can just take the machine with us and print what we need. And of course, there's a cost reduction. We're seeing remarkable cost reductions with some of the parts that we're producing. So let's go to the next slide. These are the types of parts we're producing with additive manufacturing. We could do end-use aircraft parts, tooling, of course, repairs, job aids to help things out when they're doing their work on the flight line. And then we're also doing rapid prototyping and fit checks. Next slide. All right, there's a 3-tier approach that we're approaching this with additive manufacturing. The first one, this is the Ultimaker S5. This sits on your desk. You can buy these off the commercial sales, like they're $2,500 a piece. We're giving those out to the fleets. People say, hey, Ted, why are you printing plastic parts? What are you doing these trinkets? Buttons, knobs, covers. Is that important? I'll give you an example. This little knob right here. This knob goes on a radio in our F-18, and it selects frequencies that our aircraft pilots can communicate on. We don't source this. We don't spare this. We spare the $8,000 radio because this knob broke and we didn't have a spare radio for that aircraft was down. Not mission capable. It missed its sortie. Are you kidding me? Our multi-million-dollar warfighter was sidelined for this? Are you kidding me? That's why these plastic parts are important to us. Something as small as this sidelined a multi-million-dollar warfighting aircraft. That's unacceptable. And that's why we're going after the tier 1s. The tier 2s, we've partnered with Stratasys with their F900s. You see we got a program manager out here from Stratasys. I'll give you an idea of what we're doing here. This is an environmental control system duct. This is 5 parts. This is glued together. The failure rate is awful on this part because of the vibrations in the system. Awful. Right? You see how they, look at that. You can see the glue. The failure rate of applying the glue is just terrible. Right? What we did with the F900, it lets us produce one piece. One piece. The reliability of this thing went through the roof. And if those of you guys who are maintainers, if you remember how you do your maintenance calculation, what's your maintenance, what's your reliability on this? You take each of the parts, if its reliability is 80%, you got to multiply that times each of the parts in the assembly. So you got an 80% reliable part, you got 5 of them, 0.8 times 0.8 times 0.8 times 0.8 times 0.8 is what, 50% reliability in the end? It's crazy. It's unacceptable. 80% reliability right off the bat. One part. Reduces touch labor, keeps our aircraft flying, keeps our lethality up. One more example. It's an H-1 helicopter pilot. Unfortunately, some of our pilots like to use this as a seat, right? They'll put this on the ground. This little lever right here. We don't source that. It breaks. We send the whole helmet back. $4,500. We were able to reproduce that part, like it's 90 cents, and put this helmet back in service. That's the kind of readiness and improvement that we get back from our fleet. Just a couple examples. That's tier 1, tier 2 kind of stuff. And then the last thing we're doing is we're moving into the metals. The metals is where we're starting here. We've got 10 parts out here. I think it's 15 parts. They're qualified to go on the aircraft now. It's pretty impressive what our guys doing. Here's an example. This was printed. This is a hydraulic manifold for support equipment for F-18. This big, huge hogging piece, as complex as it was 3 parts. We produced 1 part printed. Okay, so our big machines, the big metal machines, I give you an idea of the size. These tier 2 machines, they're about the size of a Chevy Suburban, about 7,000 pounds. Buying 24 of those. And then these big metal machines, about the same size. And we're buying 3 of those, going out to our FRCs, our depot levels. FRC Southeast, a Fleet Readiness Center Southeast, Southwest, and East. So those are our big machines. That's how we're breaking down our ability to produce additive manufacturing parts for naval aviation. Let's go to the next slide. Just to give you an idea where we're putting these, I'm buying 84 of these machines, and I'm fielding to 43 sites around the country, in Japan, and out in Hawaii. So that's our capability When the part comes in, when the request comes in, ultimately we're tying it to what we call digital thread. I will know where all these machines are. I will know what they're printing. I will know what the priority of the parts are. When the request comes in, I will be able to send the technical data package to the machine that's closest to the point of need, and they will print that part and return that piece of equipment or aircraft back to service. So that's how big this is, and this is where we're going with all of our machines. And I think that was the last slide that they let me show you guys. First, yeah. All right, so with that, I'll take any questions.
Do we have any questions?
Being that all those products are being able to be made within the company, what do you think the output is of all those, with all those machines that you'd be able to have statewide? Would it be able to be the same as outsourcing as well, or is it something that we have to?
So right now, typically what I handle are supply issues. If we can't get that part, they're typically coming to me pretty quick. They're saying, can you do it and how fast? So I am not competing with private industry. I will take that part. We will put it into what's called triage. We'll look at it, see if we can make it with additive manufacturing capabilities. We will tell the program office, say, hey, we got this problem. We got these aircraft down. This is what it brings you. You're waiting on this part for 6-8 months. We can get it to you in 2 weeks. Is that important to you? It is to speed up the process. Now, in some cases, the program office will come back to us and say, well, hold on. We've got a contract coming up pretty quick. We're going to have that part in 3 weeks. We don't necessarily need your help right now. Or they might say, you know what? We can't get that next contract in place for that part for 6-12 months. Why don't we go ahead and make a spare supply right here? And as soon as the new ones come in, we'll take those out and we'll replace them with the OEM parts. Your statement? Thank you.
Do we have any other questions from the floor?
Yes, sir. Jeff Sharp from Joby Aviation. Wanted to ask about additive manufacturing and airworthiness and what your efforts with the airworthiness office have been.
Yes, great question. We have what are called flight critical parts and non-flight critical parts. And we have a category for them. We call them green box, are the non-flight critical parts. They don't have to go through the flight worthiness certification and things like that. But when we start getting to flight critical parts and it's a flight safety issue, it's a whole new ball of wax. We got to put it all through testing. We got to do test coupons, strength and strain. We get our materials analysis folks. And we have to go through the ability to convince the program office through all of our testing that that part is equal to or better than the OEM part. And once the program office is convinced of that, they'll generate an ECP and qualify that AM part, or they'll stamp it as an alternate source. Thank you. Good question.
How, sorry, Bill Reuter, Roto, R Squared Solutions. I'm a former Naviair guy, but are we dialed into the RCB and some of the forcing functions to ensure that we can do the best in anticipating these kinds of things?
Great question. Thanks. I think they planted you. So the RCB is the Reliability Control Board. Anytime that there's a problem out on the flight line and the maintenance actions, they take that issue and they load it up into what's called the Reliability Control Board. There's a database, and they have to mark it. There's 3 categories. There's a supply issue, it's a maintenance action issue, or it's I think the third one was a installation issue. I forget what the third category was. But if they mark it's a supply issue, there's a thing called the Automated Degrader Tracking System that's inside RCB. If they mark it as a supply issue, a drop-down menu comes in and says, have you considered AM as a potential solution to solve your problem? That kicks over notice to me to start working on that process with the triage and let the program office know if I can help them. So yes, we are integrated into the RCB process through the Automated Degrader Tracking System. Great question. Thank you.
Ted, we do have a couple of questions coming to us virtually.
Sure.
One is how do you store the raw material to print the end product on a ship?
Oh, all right. Another fabulous question. I get this one weekly. All right. So our tier 1 machines, only the plastic machines are going on the aircraft carriers. All 11 aircraft carriers will get the tier 1 machines. We haven't quite figured out how to do tier 2 and tier 3. Again, tier 2 machines, they're the size of a Chevy Suburban, 7,000 pounds, putting that on an aircraft carrier. And then we got the environmental conditions aboard the aircraft carrier. Can't really control this, rocking and rolling. And can you still print during those conditions? Haven't worked that out yet. And then we talk about the metal machines. Will the metal machines go on a ship? I know NAVC has a metal printer that's going aboard a ship in a demonstration this fall, October, November timeframe. But right now, the storing of the powders, those metal powders, is very volatile, very volatile. And we don't have the ability to put that on a ship or handle that just yet. So that's something that's future business. Over.
Another question from our virtual audience. How easy would it be for suppliers to be able to qualify an AM part?
So everything that I just told you about how we qualify our parts is something a supplier would have to do. If he sold a platform to the government, he would have to come to the program office and prove to them that his AM part is equal to or better than the OEM part. I typically don't get involved in that process. Some of my engineers and materials people might, but I don't qualify outside vendors' AM processes.
Do we have any other questions from our floor? All right, we got another virtual one. Can we create skates for consumables that are typical IPG ones without wholesale stock?
Without full scale.
Without wholesale stock. Okay. Oh, I'm sorry. I don't know. That's good.
Can I take a look at that?
The joy of going virtually. Spares. How can we create spares for consumables that are typical? He corrected himself. No? All right.
I don't have the answer.
Any other questions? Any other questions from our virtual audience? All right. How about from our floor? Okay, Ted. Great presentation. Thank you so much
Thanks
for
your
joining
time,
us.
folks.
Thank you all
Let's
for
go
your
enjoy lunch. Great presentation. Thanks, guys.